Okay, students, so question number 3. I have already written it down. Yesterday I have given you a hint, right? So what it says in question number 3 is they have asked you to examine whether Rolle's theorem is applicable in question number 3 or not in this function. Now again I repeat, to apply Rolle's theorem, 3 conditions must be satisfied. First thing, what is that? Function must be continuous. This is the function given to you. Okay, this function must be continuous, differentiable, and f of 1 must be equal to f2. This 3 condition, if it satisfy, then only Rolle's theorem is applicable. Okay, then there will exist one point. We know that there exists one point for that differentiation will be 0. Okay, so anyway, we will check whether this at this function Rolle's theorem is applicable or not. For that, we need to find whether f is continuous. So from the function, easily you can say this is continuous. Why? Because it's a polynomial function, right? So I've already written now f is polynomial function, thus f is continuous for all x belongs to this one. So here you don't have to check by left hand limit, right hand limit, all those things. Okay, directly you can write, since polynomial function are always continuous. You can verify any polynomial you can take and can try to find out whether it is continuous or not. Okay, and we have done many questions based on that also. So this will be continuous, first thing. Second, this will be differentiable or not. So you can see we can easily differentiate this one. This differentiation of this one will be what? 2x minus 0, right? Constant will be 0, so 2x. So we can differentiate this one, so it is exist, differentiation exists. But still, if you want to verify with this one, left hand derivative, right hand derivative, you can verify with this also. X, you take any point between this, you will see both will come out same always. Between 1 to 2, don't take 1 and 2. Okay, between 1 and 2, because we know that at 1 and 2 differentiation can never exist. Okay, and in your theorem also it is given open interval. Remember, you can check that theorem well. Okay, it is given open interval, so don't take 1 and 2 here. Except 1 and 2, you can take any point between this. Okay, so you can take and check left hand derivative and right hand derivative, both you will get always same. Moreover, it's very simple from here. If you can differentiate, it is differentiable. It is, if you are not able to differentiate, not able means what? Like greatest integer function, do you know what is the differentiation of this? We don't have any identity, so through graph or through left hand derivative, right hand derivative, you can find out that one. Okay, so in this case, this is differentiable. Polynomial function always differentiable actually. Okay, so anyway, if this x exists here. Okay, so differentiation also exists. Okay, fine. Now the third condition, we will check whether it is same or not, and you will see that f1 is equal to 0, f2 is equal to 3. So obviously they are not equal, so f1 and f2 not equal means third condition is not satisfied. Okay, so Rolle's theorem is not applicable here. Why? Because first, second condition satisfied, but the third is not satisfying the condition, right? So therefore Rolle's theorem is not applicable. Okay, now what about converse? They have asked you to tell about converse also, right? Can you say something about converse of Rolle's theorem? So converse of Rolle's theorem, what you can say? So I told you, right, from reverse we will start. Whatever is your theorem, from reverse we will start that. So we want to find out first one point between 1 to 2. Again, this is open interval. Okay, so C point between 1 to 2 such that f dash C must be 0, then only we can proceed. We will show those 3 conditions satisfy or not. If it's satisfied, then the converse is true. Okay, otherwise it's not true. So in this case, first thing, to find out f dash C, to find out at this point, whatever point it is, differentiation 0 or not, first we have to differentiate, right? So differentiation is how much? 2x. Now we will find out one point we have to find, right? C we have to find between this such that this must be 0. So can you tell any point x, any x here, which you will put here such that it will become 0? Obviously 0 is the only point here, right? Between 1 and 2, can you say any point which will make this one 0, means this one 0? Obviously no. From 1 to 2, if you take any point here, x, anything you take, it will never become 0. f dash any point between this will not give you 0 here, right? So what has been written here, there exists no point C belongs to this such that f dash C is equal to 0. So you will have no points, no such point between 1 to 2 such that the differentiation at that point is 0. You will not get, right? So if you cannot get those points, then obviously converse you cannot use. Okay, so converse is not true. Clear? So these things try to understand carefully. It's a simple topic. Okay, So rest of the question I think you can also do yourself. Same way mean value theorem also, try to show those condition and then try to see whether it is applicable or not. Okay. So here also, if f is a function from this to this is differentiable function. So they have already said this time this is differentiable function. F is differentiable function. Okay. And f dash x does not vanish. Does not vanish means f dash x is not equal to 0 anywhere. Then prove that this is not equal to this. Obvious, right? This one, if f dash x is not equal to 0 at any point means what? See carefully. In this case what they have said, there is a function, question number 3, defined from close interval 5 to minus 5 to 5 to set of real number. Now it's given f is differentiable. Now we know that if f is differentiable, it will also be a continuous, right? Therefore f is continuous. Last time I told you this one, if a function is differentiable, it can be continuous also, but if it is continuous, it may not be differentiable. Okay, converse is not true here. So f, if it is differentiable, it will always be continuous. So f is differentiable implies, you can write implies f is continuous. Now f is differentiable also, continuous also, but they have said f dash x is not equal to 0. Does not vanish means what? Not equal to 0, right? If vanish means it become 0. So does not vanish at any point, they have said, right? You can see in the question it's given f dash x does not vanish anywhere. So anywhere means what? Between this point also it does not vanish, right? Vanish, I will write minus 5 to 5. They have said anywhere means I will take this one because I need this only. So if f dash differentiation does not vanish at any point, between this point you don't have any point for which this is equal to 0. You don't have any point. Means what? You can relate this one with theorem. In theorem it says that if there exists C belongs to open interval, say minus 5 to 5, then f dash C must be 0. Now if it happen, then only your theorem, what it says, f differentiable, f continuous, f minus 5 is equal to f of 5 is equal to f of 5, then there exists C belongs to this one such that this will happen. Now if this is not equal to this one, then obviously first two condition it is satisfying, f is differentiable and continuous. If this is not equal to this one, means what? There exists no point for which it is equal to 0. Means what? When you do converse, obviously this and this holding means what? One must not hold, right? One of the conditions should not hold, then only converse will not be true, right? So in this case this is not equal means one of this will not be the condition. Means differentiable continuous, it is satisfying the condition, means one of this will not satisfy the condition. Means what? F of minus 5, this implies f of minus 5 is not equal to f of 5. Directly you can write the third condition should not satisfy, then only this will happen, right? Otherwise, see, if this satisfy, this satisfy, this satisfy, this is also equal, if it happen, then we know that there will be exist there one point between minus 5 to 5 such that this will be equal to 0. We know this theorem. From the theorem we know that if f is differentiable, f is continuous, and f of a is equal to f of b, if it is equal, then we know there will exist for sure one point between a to b such that f dash of c will be 0, where c belongs to this point. So if this is equal, then obviously if these three conditions satisfy, then this will be equal. Now in this case two condition is satisfied and they have said that this is not equal, f dash c is not equal, I can say, because for any point you are not getting 0. Means what? One of the three conditions should not satisfy, then only you will get, if this satisfy, this also will satisfy, then obviously it will be equal to 0. We know that. So obviously they have said this is not equal to 0 means what? One of this means this one is not satisfying, this is not equal, then only we can say means there exists no point such that for that this one equal to 0. Okay, so directly you can write, since f is differentiable, continuous, f dash x not equal to 0, therefore f of minus 5 is not equal to f of 5. Okay. Okay, now next question number 5 I will do. 4 you can try yourself. Okay, why? Because question number 5 exactly same like number 4, only extra it's there. Okay, in this case also they have said verify mean value theorem for this function in interval this one. You can see this also verify this in interval this one till here. Now next is find all c belongs to this for this one. So exactly same way I will do this one. You can try this exactly same way. Okay, number 5. And number 6 also examine applicability of mean value theorem for 3 function given in the above exercise 2. Okay, this also you can do yourself, right? Same applicability of mean value theorem for all 3 function given in the above exercise 2. Exercise 2 means I think they are talking about exercise, this same exercise question number 2, this 3 function they are asking to check mean value theorem. Okay, whether it is applicable. Obviously in the first second it is not applicable. Why? Because this is not continuous, not differentiable. You can check this one. This will be applicable here, because in mean value theorem it here in this case why Rolle's theorem was not applicable, because fa was not equal to fb. Now in mean value theorem you know that fa is equal to fb condition is not necessary. In mean value theorem only 2 condition. What is that? F must be continuous and differentiable. If it happens, then there will exist one point between the interval such that differentiation will be fb minus fa. That condition is there. Okay, so we will do that one only. So see question number 5. So if I do number 5, you can do rest of the question yourself also. Okay, so in this case they have said verify mean value theorem for function this one. They have given x cube minus 5x square minus 3x in the interval a comma b. Now what is a? A is 1, b is 3. So simply I can say in the interval 1 comma 3. Okay, so see this function is given and x belongs to, they have given 1 comma 3. I have not written a b. Okay, now because they have already given a is equal to 1, b equal to 3. So now we have to verify this function is mean value. I can apply mean value theorem here or not. So, okay, so for this I have to check those 2 conditions is satisfied or not. F is continuous and differentiable or not. So simply you can see number 1. Now f is again polynomial function, right? Polynomial function. Thus f is continuous. Okay, continuous for all point. Also you write down for all x belongs to 1 comma 3, close interval 1 comma 3. Number 2, f dash x differentiable or not. Let's see. So I can differentiate easily this one, right? 3x square minus 10x minus 3. So this will be the differentiation of this. So we are able to differentiate means f dash x exists, differentiation exists, thus f is differentiable for all x belongs to open interval 1 comma 3, because you know at that boundary point it will never be differentiable. So in the theorem it is given open interval, and I have explained also why open interval. Okay, so 2 conditions satisfy. So obviously mean value theorem is applicable. So there will exist, therefore, okay, thus this is, therefore there will exist c belongs to open interval 1 comma 3. So be careful with this interval, don't put close interval here. Okay, there exists c belongs to this interval such that, what was the condition this time? Not 0. Okay, f dash c will be f of b minus f of a. What is your b here? Let me write down ba so that you can understand. This is theorem as well as ba is given here also, right, in the question itself, so I can use. So what is ba? You can write down here f of b, what it will be. Now you have to solve this one. f function is this one, f of b is, let me write down first number here, fb is here 3 minus a is 1 here, so 3 minus 1 2. So fb, that is f of 3 and f of 1, we have to solve first. Okay, so if you solve this f3, that is in place of x, if you take 3 and solve it, this one, you will get minus 27. Okay, and if you solve this one, f of 1, if I put 1 here, 1 here, 1 here, what you will get? 1 minus 5 minus 1. So 1 here, and this one, no sorry, this will be 3, right? So 1 minus, this will be, yes, 1. So 1 minus 5, that is minus 4, and this will be minus 3, that is minus 7, it will be, right? By 2. I hope it's correct. Okay, so minus minus, this will be plus, right? So it will be 34 by 2, which is equal to minus of, wait, okay, they have said, okay, so in this case they have also asked you to find something. Okay, yes, so f dash c is equal to how much? Minus 17. Let me check once again. So f3 minus 27. Okay, fine. Minus, this will be 1. Okay, this, yes, this should be minus minus, it should be plus, right? So if it is plus, you have to subtract this one, sorry. So this will be minus minus, this will be plus, right? So minus plus, so this will be 20 by 2, this will be 10. Okay, so f dash c, how much we got? Minus 10. From this I can, now c will be what point? I can find out from here, right? So this is an equation of c only. You can see f dash c, what it is, f dash x is equal to this one, right? So f dash c will be what? 3c square minus 10c, 3c square minus 10 into c minus 3. You have to find out what is this point. Okay, there will exist c, I have said. Now what is c? You have to find out that and have to show that point also. Okay, so you just simply have to solve this equation. Now you know, right, how to solve quadratic equation. So using splitting the middle term, you can use this and can find out the value of c here. Okay, so minus 10, if I bring this side, square minus 10c minus, this will become plus, so plus 7 is equal to 0. So you try to solve this one using splitting the middle term. Okay, 3 into 7, that is 21. So using 21, you split 10. Okay, you know that, right, how to use splitting the middle term. So you split this middle term and then solve for c, whatever comes out. Okay, you find out that value, so that will be your answer. Next, again they have asked you something. Find all c belongs to this for which f dash c is equal to 0. Now this condition, see carefully. For this belongs to this for which f dash c is equal to 0. For this, f of a, Rowe's theorem must satisfy, right? Then only this will be equal. For there will be one point for which differentiation will be 0. For that, Rowe's theorem must satisfy. Yes or no? Now here we have seen mean value theorem, we have verified. Okay, fine. So for mean value theorem, we used to find out only 2 points, that is f is continuous and differentiable. After that, we used to find out 1 point between this one such that this condition satisfies. So from this we can find out what is c here, right? Now here they have asked again just to test whether you have understood or not. Find all c belongs to this. Means you have to find all the point between this 1 to 3 such that f dash c is equal to 0. Now if some students don't understand, they will try to find out value of this also. Now you don't have to find, see here carefully. For this condition f dash c, when it will be 0? If f of a is equal to f of b, because two condition, f continuous and differentiable, satisfy. If this satisfy, then only we know that there will exist one point c belongs to interval such that your f of the f dash c will be 0 if this is equal to this. So first we will check whether fa is equal to fb or not. Okay, now second part, I will simply write second part here. Okay, this part is over, first part is over. Okay, verify mean value theorem. This is how you can verify. So exactly same way you do question number 4, exactly same way. Okay, you solve like this. So second part, what it is? So f of 1 we will find out. What is the interval? A is 1 here, b is 3, right? So f of 1 we will find out what it is. So it is f of 1 we have already find here actually. You can see -7 we got, right? -7, and we already know that f of 3 it is -27. So they are they equal? Obviously no, since f of 1 is not equal to f of 3, there exists no point c belongs to 1 comma 3 such that f of f dash c is equal to 0. There will be no point actually. They have said find all point, right? But there will be no such point. Okay, from this expression we can understand. I hope things are clear now. So you try to solve question number 4 yourself, and number 6 means this one you have to verify mean value theorem. If anything, any problem you get here, you just let me know. I will solve this and will show you. Okay, so in the next video I will show you all the mistakes you have done in midterm exams, all those questions. Okay.